Hey, 10th grade. Today's lesson will be the law of sines. Objectives: solve triangles by using the law of sines if the measures of two angles and a side are given. And find the area of a triangle if the measures of two sides and the included angle or the measures of two angles and a side are given. Okay? So the law of sines can be used to solve triangles that are not right triangles. Okay? So far we have been working with right triangles, triangles that have a right angle, an angle that measures 90 degrees. Now we're going to be solving any other triangles that are not right. So that means we're going to be solving acute triangles or obtuse triangles, right? So let triangle ABC be any triangle with A, B, and C representing the measures of the sides, opposites, the angles, with measures A, B, and C respectively. Then the following is true. Side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Okay? This is the law of sine. These equations represents the law of sine. So if we look at example 1, it says solve triangle ABC if angle A equals 33 degrees, angle B equals 105 degrees, and side C equals 37.9. So we have the triangle ABC. We have angle A, 33 degrees, angle B, 105, angle C, 37, angle C, and side A. I meant side B, 37.9. Okay? So remember, to solve a triangle means to find all the missing sides. So we have angle A, 33 degrees. We have angle B, 105 degrees. We are missing angle C. We have side B, 37.9. So we are missing side A and side C. Okay? So to solve this triangle, we have to find angle C, side A, side C. So we're going to solve this triangle using the law of sines. Okay? Now notice, we know side B and its respective angle B. Okay? So we can find side A if we want to by using the law of sines. The law of sines says side A over sine of A equals side B over sine of B equals side C over sine of C. This is also true that A over sine of A equals C over sine of C. Okay, transitive property. Now, so we can apply the law of sine and saying A over sine of A equals B over sine of B. Okay, why I'm using this part? Because I know the value of side B and I know the angle B. So if we substitute, do we know the value of A? No. A over sine of angle A, 33 degrees, equals side B, 37.9, over sine of B, sine of 105. Now, how do we solve this? If we look at this, this is a proportions. How do we solve proportions? Cross multiplications. So we get that A times sine of 105 degrees equals 37.9 sine of 33 degrees. Now how do we leave A by itself? Dividing both sides of the equation by sine of 105. So we get that A equals 37.9 sine of 33 degrees over sine of 105 degrees. So let's take out our calculators. So we have 37.9. Okay, look, always make sure that your calculator is in degrees. Okay, 37.9 sine of sine of 33 equal divided by sine of 105 equals. So side A is equal to 21.4. So A equals 21.4. Okay? So now we have angle A, side A, angle B, side B. We're missing angle C. How can we find angle C? Using the triangle equation. Okay? Angle A plus angle B plus angle C equals 180 degrees. 33 plus 105 plus C equals 180 degrees. 33 plus 105, that's 138, plus C equals 180. C equals 180 minus 138. So that means C equals 42 degrees. Now we know the measure of angle C, 42 degrees. So what are we missing? We're missing side C. And again, we can apply the sine formula, the law of sine. We can use B over sine of B equals C over sine of C, or we can also use A over sine of A equals C over sine of C. Okay? So in this case, I'm going to use, to find C, B over sine of B equals C over sine of angle C. So that means 37.9 over sine of 105 equals C over sine of 42 degrees. We do the cross multiplication again, so we get 37.9 sine of 42 degrees equals C sine of 105 degrees. How do we leave C by itself? Dividing both sides of the equation by sine of 105. So we get that C equals 37.9 sine of 42 degrees over sine of 105. Okay, so let's take out our calculators, and we get 37.9 sine of 42 equal divided by sine of 105. Sorry, 105. That is equal to 26.3. C equals 26.3. So now 26.3. So here we have solved the triangle. Notice we have the three angles: angle A 33, angle B 105, angle C 42, and we have our three sides: side A 21.4, side B 37.9, side C 26.3. So this is how we solve a triangle using the law of sines. Now, example 2 says, refer to the application at the beginning of the lesson. How far is the fan from home plate? So if we read the application, it says, A baseball fan is sitting directly behind home plate in the last row of the upper deck of Comiskey Park in Chicago. The angle of depression to home plate is 29 degrees 54 minutes, and the angle of depression to the pitcher's mound is 24 degrees 12 minutes. In Major League Baseball, the distance between home plate and pitcher's mound is 60.5 feet. How far is the fan from the plate? So, here we have created our triangle. Pitcher's mound, home plate, and our fan. He's sitting over here on the upper deck of the stadium, right? So we know that the angle of depression to pitcher's mound is 24 degrees 12 minutes, and the angle of depression to home plate is 29 degrees 54 minutes. So what would be the measure of that angle and this angle? Okay, I'm going to call this theta 1, and I'll call this theta 2. Now, theta 1 is going to be equal to 29 degrees 54 minutes minus 24 degrees 12 minutes. This minus this will be equal to theta 1. So that we write 29 degrees 54 minutes minus 24 degrees 12 minutes. So our calculator, 29 degrees 54 minutes minus 24 degrees 12 minutes, that's equal to 5 degrees 42 minutes. Theta 1 equals 5 degrees 42 minutes. Okay. Now, what would be the measure of theta 2? Notice, these two lines are parallel lines, and this is our transversal line. So, this angle and this are alternating interior. That means that theta 2 will be equal to 24 degrees 12 minutes. Okay? Now that we know this information, what else do we know? We know that the distance between the pitcher's mound and home plate is 60.5 feet. So let's name this triangle. I'll name this triangle A, B, C. So triangle A, B, C. We're looking for the distance from the fan to home plate. So we have to find side A. Remember, we always name the side of the triangle opposite to the angle. So if this is angle A, this is side A. If this is angle C, this is side C. If this is angle B, this will be side B. So what we're looking for is angle side A. So what information do we have? We have angle A equals theta 2, 24 degrees 12 minutes. We have angle C, 5 degrees 42 minutes. And we have side C, 60.5 feet. And we're looking for side A. So since we know side C and its respective angle C, we can apply the law of sines. A over sine of A equals C over sine of C. Okay, we don't know the value of A. A over sine of 24 degrees 12 minutes equals side C, 60.5 over sine of 5 degrees 42 minutes. Cross multiplications. A sine of 5 degrees 42 minutes equals 60.5 sine of 24 degrees 12 minutes. Okay? Now to find A, we have to divide both sides. Divide both sides by sine of 5 degrees 42 minutes. Sine of 5 degrees 42 minutes. So we get that the distance the fan is from home plate will be 60.5 sine of 24 degrees 12 minutes divided by sine of 5 degrees 42 minutes. So we use our calculator. 60.5 sine of 24 degrees 12 minutes divided by sine of 5 degrees 42 minutes. That's equal to 249.7. 249.7 feet. Okay, so that will be the distance the fan is sitting behind home plate. 249.7 feet. Now, area of triangles. Let triangle ABC be any triangle with A, B, and C representing measures of the sides opposite the angles with measurements A, B, and C respectively. Then the area K can be determined using one of the following formulas. K equals 1/2 B times C sine of A, or K equals 1/2 A times B sine of C, or K equals 1/2 A times C sine of B. So if we look at example 3, find the area of triangle ABC if A equals 4.7, C equals 12.4, and angle B equals 47 degrees 20 minutes. So we know A equals 4.7, C equals 12.4, and angle B equals 47 degrees 20 minutes. So which of the three formulas can we use? Side A, side C, angle B. Side A, side C, angle B. We're going to use the formula K equals 1/2 A times C sine of angle B. All we have to do is substitute. K equals 1/2 times A, 4.7, times C, 12.4, times sine of 47 degrees 20 minutes. So all you have to do in your calculator is multiply, right? So that means 1/2, 0.5 times 4.7 times 12.4 times sine of 47 degrees 20 minutes. And your area will be 21.4 square units. That will be the area of that triangle. Notice in this exercise we knew two sides and an angle. Okay, we knew two sides and an angle. Okay, so in example 3 we knew two sides and one angle. Now look what happens when if we have two angles and one side. Let triangle ABC be any triangle with A, B, and C representing measures of the sides opposite the angles with measurements A, B, and C respectively. The area K can be determined using one of the following formulas. K equals A squared times sine of B sine of C over sine of A. Or K equals half of B squared times sine of A sine of C over sine of B. And finally, K equals 1/2 C squared times sine of A sine of B over sine of angle C. Now, example 4. Find the area of triangle DEF if side D 13.9, angle D 34.4 degrees, and angle E equals 14.8. Okay? Notice they give us two angles. Okay? In this case, they gave us angle D and E, and we know side D. So, the formula for this area will be K equals 1/2 D squared, because that is the angle that we know, times sine of E sine of F over sine of D. Notice, if we know angle side D, then when we divide the signs, make sure that the angle in the denominator will be the opposite of the side that you know. So, for this, we have side D equals 13.9, angle D equals 34.4, angle E equals 14.8. What are we missing? We're missing angle F. So how do we find angle F? Using triangle equation. D plus E plus F equals 180. 34.4 degrees plus 14.8 degrees plus F equals 180. 34.4 plus 14.8, that's 49.2 degrees plus F equals 180 degrees. Subtract. So we get that F equals 180 minus 49.2. So we get 130.8. 130.8 degrees. So now we have our missing angle. So now we can use the formula. K equals 1/2 D 13.9 squared sine of E 14.8 times sine of F 130.8 degrees divided by sine of D 34.4 degrees. Okay, so in our calculator, 0.5 times 13.9 squared times sine, repeat, 0.5 times 13.9 squared times sine of 14.8 times sine of 130.8, that's equal, divided by sine of 34.4, and that's equal to 33.1. So K equals 33.1 square units. Okay, so that's how to find the area of a triangle with two known angles and a side. Two angles and a side. Okay, so your homework number 3 will be page 316, problems 6 through 24, even. Okay, homework number 3, page 316, problems 6 through 24, even. Okay guys, see you next week.